Okay, so for this week, we're going to discuss algorithm analysis. So sa algorithm analysis, we can define this as what we refer to the process of deriving estimates for the time and space needed to execute the algorithm. So in your LMS, you have there a video wherein it explains about what is an algorithm and how it is used in a simple application. No? So nandun, kung paano tayo gagawa ng algorithm to make things easier for us. So yun yung silbi ni algorithm. It is a way for us to execute or uh, to solve something wherein na hindi na natin siya kailangang manumanuhin, no? So this algorithm analysis paves way to the possibility that we can cut the time needed, no, to solve something. So nandito yung involvement ng time and space. Bakit po kaya sir sa algorithm time and space ang involved? So yung time is when we do an algorithm, we want to have the shortest time possible. Okay, so sabihin gusto natin na mas mabilis na process while the space is also hand in this in a matter of yung space natin sa let's say hardware or software or yung ating pinaka system, it takes us lesser space or lesser hardware to function para po makakuha tayo ng same output. Kumbaga, in algorithm analysis, it is important for you to use lesser space at a shorter time, but still paving way to having an optimum result. No? So, kumbaga parang gagamit ka ng konting system sa computer mo, konting konting memory lang ang gagamitin mo, pero mas mabilis mo siya ma-execute at maganda yung resulta. So yun yung gusto ni algorithm, no? Kailangan yun yung maging ideal process natin in order for us to get the estimates that we want. Time needed to execute an algorithm is a function of the input. So when we say algorithm kasi, it is a set of instructions that we give computers to execute. Okay, so tayo yung nagbibigay nun. Okay, yung computer is what it does is it executes only but it does not program itself, 'di ba? Hindi naman niya kaya i-program ang sarili niya. Tayo yung nagpo-program sa mga computer. So by definition, we all know that data structure is a systematic way of organizing or accessing data. So tayo din yung nagawa ng paraan para magkaroon tayo ng mas organized or mas maayos na form of data while letting algorithm perform the task in a finite amount of time. Okay? So the once we have organized our data very well and neatly, doon papasok si algorithm. Kasi kung ang gagawin mo is you will just let your data flow inside, no, hayaan mo lang siya pero hindi siya organized, hindi siya maayos or hindi siya neat. Okay, hindi naka set up yung data for it. For the algorithm itself. So mahihirapan yung algorithm mo. Thus, pag nahirapan si algorithm, mas mahaba yung magiging time to execute. No? So, imbis na makuha mo yung gusto mo in a shorter time, pwede pa yung mas humaba pa kasi algorithms can be very very unpredictable. Pwedeng mabilis lang siya mag-execute, pwedeng matagal, pwedeng umabot ng isang araw, isang taon, who knows. Yun po ay naka-base po doon sa desire natin na makuha yung estimates or yung derivation. Then we have here best case time. Okay, so ang sabi do sa best case time, it is the minimum time to execute the algorithm. So when we say best case time kasi, it can be used to improve the accuracy of the worst case analysis. Ibig sabihin po, si best case time, ito yung gumagamit ng lesser time and space pero mas optimal yung output na naibibigay niya, no? So sa best kasi it is the minimum steps, no, that is important because the minimum steps in the best case time is the is lowest, no, very low with respect to the input data n. Okay, so yung input data mo is not relative to the time, hindi siya ganon ka correlating kasi ang best case time natin should be again shortest time possible na pwede. While the worst case naman is, kaya siya tinawag na worst kasi maximum time ang kanya with respect to the input data n. So while yung average case time naman is average lang siya, neither maximum or minimum time to execute the algorithm. But in best case kasi, it is used to describe the computer science to describe algorithms behavior under optimal condition. Kumbaga, in best case time, ito yung gusto natin or ideal talaga nating desire for the system to operate. So what's an example for that? So example natin is yung linear searching natin wherein yung desired element na gusto nating makuha is yung talaga yung unang lalabas dun sa listahan upon searching. Okay? So yun yung gusto natin. That's the best case possible. No? So yung worst case natin is if the desired element does not appear or it is the last on the list. So si best case is the least widely found case time used in computer science. So next is worst case time. So worst case time natin is the maximum time needed to execute the algorithm. So pag sinabi naman nating worst case time, so for this particular timing, ang concern kasi niya is yung time natin, 'di ba, is important. We are measuring time and we are seeing time as a precious resource, 'di ba? So kailangan po kung maximum time ang kailangan niya, there is a guarantee that the algorithm will finish on time. Okay? So mahirap kasi na mag-waste ka ng let's say 1 hour for this algorithm pero hindi mo naman makukuha yung desired output mo. So yung time kasi natin once spent, it cannot be brought back, no? Hindi mo na maibabalik yan. Hindi mo naman pwede sabihin na nasayang na 1 hour is ibabalik mo muli. So kailangan sa worst case time natin, we have the guarantee that the algorithm will finish on time. While the average case time naman, yung number of steps niya is just average, no? So these are the most commonly used algorithm analysis. So analysis of algorithms. So when we say analysis of algorithms, we have here the scripture that in computer science, the analysis of algorithms is the process of finding the computational complexity of algorithms, the amount of time, storage, or other resources needed to execute them. Usually, this involves determining a function that relates the length of an algorithm's input to the number of steps it takes, or its time complexity, or the number of storage location it uses, or its space complexity. An algorithm is said to be efficient when this function's values are small or grow slowly compared to the growth in the size of the input case inputs to the algo. Okay, so ano po kayang ibig sabihin po no, sir? So ang ibig sabihin po kasi no that the running time is relatively proportional when input a data size, a specific data size. Ibig sabihin the higher input size or the larger input size that you are giving to a system or a program, the running time increases with respect to that, no? Mas marami siyang i-analyze, mas matagal siya magra-run. So ang mga factors na nakaka-affect sa ating running time are the hardware and software environment. Okay? So ano po 'yon? So as you can see there in the paragraph, the time and space complexity, what I've said earlier, is also into consideration. So the time complexity natin is yung number of steps while yung space complexity natin is yung storage. So yung efficiency of algorithms natin is high or usually high when yung function values natin are small or grow slowly compared to a growth in the size of the input. Ibig sabihin po, dapat inversely proportional yung ating running time doon sa input natin. Ibig sabihin, even though we are increasing the input or we are highly maximizing the input, the running time must be not directly proportional to that. Ibig sabihin, it could be much slower or much faster pala, no, kung itataas mo yung data set or yung ating gusto mong ipamine na data, pero dapat yung running time mo should be relatively low. Kailangan hindi siya matagal, kasi pag matagal yung ating running time, so it would be a loss of your resource of time. Okay. So usually this involves determining a function, no? So yung function f of n natin is proportional at some point to the input size n. Always remember and take note that the function f of n is proportional to the input size n when it comes to your running time. So the term analysis of algorithms was coined by Donald Knuth. Algorithm analysis is an important part of a broader computational complexity theory, which provides theoretical estimates for the resources needed by any algorithm which solves a given computational problem. These estimates provide an insight into reasonable directions for search for efficient algorithms. As I've said earlier, these algorithms are made to be efficient. So kailangan para ma-measure kasi natin ang efficiency ng ating isang material or ng isang process, it is divided into two. We can use experimental or theoretical analysis. So when we say experimental, we use the actual set or kung ano talaga yung time lapse ng ating system when running. While yung theoretical kasi natin is ano yung by the book na dapat niyang speed. So then we compare that both kung ano yung magiging error or percent error or yung lagging and difference po nilang dalawa. So kailangan yung efficiency natin is usually measured para malaman natin if the algorithm is not buggy or hindi po siya mali or may something tayong pwedeng i-fix. So kung mas matagal yung system mo na nagre-render, so kailangan po is ibabasahin muli natin yung program, then you use analysis with that kung ano yung mga function natin na pwedeng bawasan mo ng step size, okay, or kaya ng steps para po mas mapabilis natin yung system without compromising your output. So cost model. So when we say cost model, so sabi dito, time efficiency estimates depend on what we define to be a step. For the analysis to correspond usefully to the actual execution time. The time required to perform a step must be guaranteed to be bounded above by a constant. One must be careful here. For instance, some analyses count an addition of two numbers as one step. This assumption may not be warranted in certain contexts. For example, if the numbers involved in the computation may be arbitrarily large, the time required by a single addition can no longer be assumed to be constant. So when we say cost models kasi is what we define as the importance of having the relativeness of time, no, kung ano yung pagpapahalaga natin doon sa oras na nagagather or na use ng ating program. So it can be divided into two, no? So the two cost models that we generally use, first is the uniform cost models, wherein it is stated here that this model assigns constant cost regardless of size of numbers. So kahit ano pa po yung ating numbers na i-input sa system, there is a uniform cost or the constant that we will give to the system. While when we use logarithmic cost model naman, this assigns cost to every machine operation proportional to the bits involved. Okay? So sabi dito, the logarithmic cost is commonly used in the cryptography as an arbitrary precision arithmetic. Okay. So sa runtime analysis, so as I've said earlier, no, it is important for you to understand what are the affecting factors. Okay, so as you can see here, the definition of runtime analysis, it is a theoretical classification that estimates and anticipates the increase in running time or runtime of an algorithm in its input size, and it is usually denoted as n increases. Okay, so as I've said earlier, the algorithms is highly dependent on your input. So the input is your decision kung or your problem. So yung problem po na kailangan nating i-solve is dependent on your data set na ibibigay sa system natin to program, no. So upon giving a set of instructions or the algorithm to the program, it is siya na yung bahala doon. Pero yung time na iraran niya yon is not predictable, pero pwede mong i-observe. Okay? Pwede mong i-observe para malaman mo what is the average runtime of the system. So runtime efficiency is a topic of great interest in computer science, wherein we commonly use probability and statistics para maintindihan mo what is the trend or what is the history of the running time of your specific program. So it highly matters because you can understand whether to fix something or to shortcut something, or hindi pa naman shortcut, parang to make something more simpler, no. So some programs tend to become more complex, and the more complex your program is, the harder or the longer time the program will run it. Okay, so the program can take seconds, hours, and even years to finish executing, depending on which algorithm it implements. So especially when you go to the science of data mining, machine learning, and neural networks, wherein the program will decide on your problem. So mas matagal yung iraran niya. So kailangan you need to fix your code or your program para po mas magkaroon ng shorter running time siya, mas mabilis. While software profiling techniques can be used to measure an algorithm's runtime, in practice, they cannot provide timing data for all infinitely many possible inputs. The latter can only be achieved by the theoretical methods of runtime analysis. So, yun po ang ating runtime analysis. So, we take regards of your running time, kung gaano siya kabilis or kung gaano siya kabagal with respect to your program. It is important for you to understand that the time is yung time yung dinidiscuss natin today, and space. No? So there are many terminologies that we have discussed today, but time and space are the relatively ones important right now. Okay, so yung time natin we need to have a shorter time in running our program, and space or the smallest amount of storage for us to use in running the program. Yun po yung mahalaga doon, no? So it is important for us to do that. Okay, so that would be for your runtime analysis. So again, to measure your efficiency of your program, you need to have an experimental and theoretical analysis wherein we need to find the difference between them and calculate for the percent efficiency. Okay. So that would be all for your week 4.